Differential equations, type 2, real world, A, linear motion. In 2014 10a, we had a particle moving in a straight line experiencing a retardation of 0.7 v cubed meters per second squared, where v meters per second is its speed. It takes 0.04 seconds to reduce its speed from an initial value of 200 meters per second to v1 meters per second. And the first thing they want us to do here is to find the value of v1. Okay, so what are we given? Well, we're given the retardation, okay, and we have to remember the retardation is basically another way of saying deceleration. So if acceleration is the letter A, then retardation must be given a negative value. So you have to always be careful with that in these questions. So that's the equation that we're going to be basing our integration on. We now have to look at our start and end limits to decide which form of A we're going to use. In other words, are we going to be using v dvds or dvdt? So here what we have is our start limits. And at the start we can see that our velocity is 200 meters per second. And that starts when t is 0. If I look at my end limits, well, then what I have is I'm looking for v1, so I'm trying to find the value of v1. So I'm going to say the final velocity is v1, and this happens when the time is 0.04 seconds. So we're clearly looking at our limits in terms of v velocity and t time. So therefore, I'm going to say A is dv dt. So the rate of change of velocity with respect to time. So therefore dv dt is equal to minus 0.7 v cubed. So if I rearrange that to get all of the v's on the left hand side, well then I'm going to have 1 over v cubed dv is equal to minus 0.7 dt. Now you can of course bring over the 0.7 if you wish. So then if we're integrating, I'll write 1 over v cubed as v to the power of minus 3, and then putting in my limits. So my upper limits are always my end limits, and my start limits are my lower limits. Okay, so let's integrate. So if I integrate on the next page, we have v to the minus 3. Well, if I add 1 to the power, that becomes v to the power of minus 2, dividing by my new power with my limits of v1 and 200. And if you integrate minus 0.7 with respect to t, well, that's minus 0.7 t within the limits of 0.04 and 0. So subbing those values in, well, v to the power of minus 2 can be written as 1 over v squared, and that's times minus a half. So that's minus 1 over v squared, just before I sub in my limits to make it a little bit tidier. Okay, so now I'm going to sub in v1. And of course, it's always upper limit minus lower limit. So it's going to be minus 1 over 200 squared is equal to minus 0.7 times 0.04. And then that's minus 0. Okay, so on the left, that gives me minus 1 over, there should be times 2 there, minus 1 over 2 times v1 to be squared, plus 1 over 80,000 is equal to, everything on the right-hand side there simplifies to minus 7 over 250, if you want to keep them all in fractions. And then if I multiply across by my lowest common denominator, which would be 80,000, then that gives me minus, so lowest common denominator, 80,000 v1 squared, then that gives me minus 40,000 plus v1 squared is equal to minus 2,240 v1 squared. So that was common denominator, 80,000 v1 squared. Okay, and therefore getting all the v1 squareds to one side. Well, that gives me 2,241 v1 squared is equal to 40,000. So v1 squared is equal to 17.849. And therefore, if I get the square root, I get v1 is equal to 4.225. And again, we were given units in this question. We were. So, of course, our units have to be in our answer for meters per second for our velocity v1. Okay, so we had 15 marks going for that part of the question. So for setting up our integral, we had 5 marks. For integrating correctly, we had 5 marks. And for getting our v1, we had another 5 marks. Okay, so for part 2 then it says the distance travelled during this 0.04 seconds. So for our distance, well, what do we know? Well, we have our acceleration. It's our minus 0.7 v cubed. And of course, the acceleration can be written in terms of our distance and our velocity. In other words, acceleration can be written as v dv ds. So the velocity times the rate of change of velocity with respect to displacement. And that's equal to minus 0.7 v cubed. So therefore, what's our start limits in terms of displacement and velocity? And what's our end limits? Well, we know at the start that the velocity is 200 meters per second. And we know that it hasn't moved. And at the end, well, we've just worked out that its velocity is 4.225 meters per second. That's because, of course, we were looking at the time frame of 0 to 0.04. Okay, so therefore, that's the only reason we're using this velocity. And therefore, S is what we're trying to find. Okay, so let's rearrange this equation so that we get all of the v's on the left and everything else on the right, the s's. So we're going to have v divided, of course, by v cubed dv is equal to minus 0.7 times ds. So in other words, that's going to be 1 over v squared dv is equal to minus 0.7 ds. And of course, if I'm setting that up as an integral, well, it's going to be v to the power of minus 2 dv minus 0.7 ds, upper limits, don't know for s, and v it's 4.225, lower limit for s is 0, and lower limit for v is 200. Okay, so integrating then, so if I add 1 to the power, I get v to the power of minus 1 divided by the new power, and that's the limits of 4.225 and 200. And that's equal to minus 0.7 s within the limits of s and 0. Okay, so if I sub into both sides with my limits, that gives me minus 1 over 4.225, because v to the power of minus 1 is 1 over v, of course. And then subtracting my lower limits, I end up with plus 1 over 200. And on the right hand side, when I sub in for s, that gives me 0.7s, and of course minus 0. Okay, so getting s on its own then, if I divide the left hand side there across by minus 0.7, that gives me 0.33, and of course we have to put in our units because units were given, and therefore that is meters. So there was another 15 marks going for this question. So again, setting up our integral, we had 5 marks. Integrating, we had 5 marks. And getting our final answer, we have 5 marks. And of course, when we're going back to those integration values, you know, you can of course take out your minus 0.7 outside your integral sign. You know, that's up to yourself. Take out your constants. Everyone can write them, these questions, their own way, okay? All right. So we had 30 marks in total. So let's just put that at the start. So, again, nice little question that.